Hi everyone, welcome to my presentation, Gamedev through the eyes of a backend engineer. Today I want to take you all for a little bit of an adventure through the world of game dev and its tools and a little bit of a backend. About me, I'm Robert. I have spent over 3 years of my life as a Scala developer in one of the software houses in Poland. Then things happened and I had a little break and started working as a gameplay programmer in 11-bit studios, creators of Frostpunk and This War of Mine. And as a quick reminder, if you want to ask any questions throughout this presentation, just use the Slido with the code. Today's presentation will consist mainly of two parts. The first is like a little bit of an introduction to the domain of game dev and to what kind of tools are being used and why. And the second, more meaty, more juicy part is the Unreal Engine's toolkit for programmers. So what it's actually like to program in Unreal Engine. We'll see a lot of visuals regarding like testing, debugging, visual scripting, and how the code differs from what you might be used to. So without further ado, let's get started. Game dev is, by its nature, a creative work. And what it means is that we as developers, we do not always know if the players will like our game. We want to create something that is fun, but what is fun, really? Oftentimes, fun isn't the only factor that we want to accomplish. Sometimes we want to make the players think. We want to convey a certain message, and it is best when, in such circumstances, that it is amplified by the theme, by the design, by the art style of the whole game. And to achieve this, game studios generally employ a diverse set of specialists in the form of artists, designers, engineers, writers, sometimes referred to as narrative designers, producers, marketing, and QA. And all these different team members are highly specialized, which means that artists can deal with 2D, with 3D, they can do concept art, they can do animation, they can do lighting, audio. The designers can deal with combat, they can do user experience, they can do level design, quests, and there are different designers that do that. And in terms of engineers, oftentimes you will see like engine engineers, gameplay programmers, graphics programmers, networking, UI, AI, and animation specialists. And all these team members use different tools for their daily job. But we'll not focus on like Photoshop or Motion Builder for the artists, but instead we'll focus on the tools that programmers use. And there is not that big of a surprise here at start. Like we've got the IDE, we've got the engine, we've got the version control, some kind of automation, we've got a shared space to share documentation, we've got Jira because why not? We need to keep track of our issues. And just so you know, that's what Unreal Engine looks like. But where I want to pause for a moment is in the space of IDEs, because until very recently we've been living in a world without the JetBrains, and they are slowly starting to creep into game dev. And I think this month JetBrains Radar has been released, and what it does is provide a lot of quality of life for developers. More and more studios are now trying it out and adapting it. For me personally, it makes me very hopeful for the future of tooling in game dev. But perhaps what's more interesting is that the Radar is not ideal yet. It does not have some kind of console integration that Visual Studio has out of the box. And when you're working in a studio that deals with consoles, you might see these strange devices lying around in the office, and they are called the dev kits. They're basically the not yet consumer-ready versions of the consoles. In this photo, you can see the dev kits for PlayStation and for Xbox Series X. And apart from the hardware that's identical to the ready version, there will also be software available for like developers to test and actually work on the consoles. There is, however, one issue, and that COVID happened. So what about remote? Will studios just buy every single person a console? And that's not necessarily the case. In general, COVID made studios adapt, and some studios chose to have like workstations at home. Some studios introduced like proxy machines and VPNs, so you connect via like remote desktop to a workstation in the office. And what it also meant is looking for a way to develop on consoles, because it's just not feasible to buy every single person in the studio a console. And console manufacturers actually did provide tools to remotely test consoles and develop on them. There's also a need to find an alternative for remote desktop, because it's not really fit for high FPS work that's really needed when working remotely in a game engine. And an example of such solutions, just so you know, is Splashtop. But even more interesting is perhaps the version control. When you work in IT, what you're probably used to is working with Git and Git only. However, this isn't the case for game dev, and our default is Perforce by general, sometimes SVN. And there's a couple of reasons why. One of the main reasons is that it's centralized, and at the end of the day, we have a single source of truth, which is our game. And it also introduces a very important feature called binary files locking. In general, when working with text files, with code files, what happens is that you edit them as normal as you would do in Git. However, there are like binary files that are either like textures or stuff produced by the engine that we do not know the internal structure of, therefore there are no merge tools to merge them efficiently or effectively or in any other way. And that creates an issue. But what binary files locking tries to solve, how binary files locking works is that when a person in a team wants to modify a file in Gamedev, they will just check it out, they will acquire a lock for this file, and any other person then cannot modify and submit any changes to the repository that contains this file. But this introduces another issue, which heavily disincentivizes code reviews. Because now you can have a little bit of a race condition here. Because a person who just made the changes, they made a pull request, they made a review, are waiting for a reviewer to check out their work. They do not own the file anymore. And someone else just may snatch the file, and suddenly you have a problem because the reviewer needs to go to that person so that they actually revert the changes so they can have a look. In practice, it means that binary files are rarely looked at, but it is also essential that they should be looked at during reviews. Perforce also is quite fast, and it handles large binary files well. I haven't really had any issues with it compared to Git, which sometimes did have issues for me. There is also a lot of built-in integration within Unreal Engine already, and even outside of it, which makes it even more of a default choice for game dev to actually use Perforce, sort of like processes in Unreal that Epic actually speaks about use Perforce, and therefore they're a bit easier to mimic. And what we also do have is graphical user interface, which means that all of your team members, like artists and designers that are not necessarily used for working with console, writing in console commands, will be able to interact comfortably with the version control system on their own. One other interesting friend from IT that made its way into game dev is Jenkins, and it's primarily used for two things. For automated building on various targets, it will build your game for you, and it will be used for running tests, as you would perhaps expect. However, it introduces another issue that the next tool is going to try to solve. And the next tool is Unreal Game Sync. What it is it's a way for Epic, it's like a wrapper of pulling from Perforce that automates certain syncing processes as is trying to work around the problem of incompatible binaries. And to understand the problem, we need to have a look at two typical syncing overheads. As a programmer, what you do when working with Unreal is like sync perfors, resolve conflicts manually or automatically. You still have to probably click sometimes. But an important step in all of this is that you generate project files, or otherwise your IDE will not just see all of the files in the project. It will compile, but you will not be able to work efficiently with it. And then you maybe build and run the project. What artists do in the upper graph, or what they don't do, is they do not generate project files. They do not have IDEs. They do not have the compiler. So instead, they sync editor binaries from perfors. And the problem is, who is going to produce those binaries? Usually it's Jenkins, and can do it automatically. But that once again creates a little bit of a race condition here. Someone can just submit changes, and you may want to, and an artist may want to download them by accident just after the submit, and Jenkins haven't really finished building the binaries yet. And then the editor will not start. You have to wait. It's a little bit annoying. You need to wait here. And UGS tries to solve that by having a look at perfors and integrating it with perfors and looking at the binaries that you have, and will only allow you to sync with the binaries that you actually have and with the change list, so like the branches of perfors of sorts that you have the compatible binaries for. Apart from that, it will allow you to automate all these processes and like run them at, like, for example, 6 a.m. every morning if you wish to do that, or every time you want to use it with just one click. We talked a little bit about like building, but how about the sharing the actual builds? And it turns out that Steam is quite frequently used for like for work in game dev, and it has a feature called branches or betas, which in general means that you can have different versions of your application, of your game on Steam, both publicly or privately available. And you can choose who you share it with via access codes that you share with specific people. It's definitely more convenient than sharing like zip files over email or Google Drive or NFS or stuff like that. And as an example of some of these branches, I pulled some of them from SteamDB's page of Cyberpunk, so that you can have a look at some of the internal development branches, like testing branches for QA, some content previews, PC previews builds, stuff like that that are actually being frequently used. So as a quick summary so far, perfors as the version control of choice with binary files locking. There's Jenkins for automation, UGS for more automation of the syncing overhead, Steam for showing the builds, and Rider as a good things to come, as a sign of good things to come into the IDE space. But let's talk about the meaty part, about the programmer in game dev and what's actually like to code in Unreal, how it's actually like to debug and test. And as a gameplay programmer, as a game programmer in general, you touch in Unreal pretty much 5 different things. It's your game's code, it's the Unreal Engine source code, because it's open source, provided you register on a website. Any engine modifications which your studio might have introduced, because it's quite easy to do them and achieve things like a crash reporter that will directly report to your engine programmers instead of epics, so they can easily look for issues in the systems that you have created. You may also be touching the plugins code, because imagine a situation in which you're updating a version of the engine to the latest one, but the plugins have not, third-party plugins have not yet caught up. And you might really want to use those new extra engine features. In such cases, it's possible to touch the plugin source code or just throw them away sometimes. And the big part of what you do, apart from writing normal code is touching the blueprints and so the visual scripting in engine, which we'll talk about in a moment. But for standard coding, there's a new flavor of C++ in Unreal Engine. And it's something that's referred to as assisted C++. It's assisted and different in a way that standard library is pretty much not used. You're not using STD in any way. Instead, Epic and Unreal's framework have their own implementations of like vector, of arrays, of map, of every single map that you may actually need. And the whole framework is heavily prefix-based, which means that if you have a class that inherits from your object, its name needs to start with U, or it will not compile. The Unreal Build tool will not let you compile that. Another thing is that the whole framework introduces annotations, which are called specifiers, and there are macros underneath. And there is garbage collection. So you need to watch out for your pointers that you didn't register to the garbage collector through uProperty specifier. There are some custom features like interfaces, which did not make its way into C++ normally, and the way they are implemented in Engine are a bit clunky and not necessarily work. But you will see as an interesting example what they look like. And instead of like CMake or other things that are used in C++ building, you have Unreal Build tool, which is a completely custom build tool for Epic to make its games. And when it comes to the specifiers, as you can see in the last 3 lines of this example code, this class has a uProperty that's visible anywhere, and it's of type pointer to static mesh component called base mesh. Writing such code interfaces with the engine. It would allow you to see and modify the actual component inside blueprints and inside your engine. As you can see here, you have the component base mesh, and you can, for example, set it to be like a little bit of a treasure chest or whatever else your game desires. I mentioned interfaces and that clunky implementation that we have. You can see in this code example, that's a generated interface with a function. So the interface here is actually 2 classes. One, from what I heard, is used for the reflection system of Unreal, and the other is used everywhere else, and that's where you implement the actual function, which is going to be the shared behavior. But why do they call it interfaces? Why it's not just an abstract class, I'm not necessarily sure. That's what everyone is using, that's what we have to deal with in interfaces. And to make things worse, you cannot even pass them normally like you would do in Java, and instead need to wrap them up in a T-script interface, or otherwise it will not compile. And having assisted C++ isn't even doesn't mean that you lose all the joys of working with the compiler of C++. So in this particular example, I hope you can see, is an unresolved external symbol compiler error, which you might think, hey, maybe I forgot to add a function to the header file. Maybe I forgot to do some kind of include. But actually, the problem is that I forgot to add a module to the project. So like, thank you, C++ compiler, you're doing great, you're very helpful. Another important aspect of writing code is the blueprints. And what they are is like visual node system that correspond to function calls. But what's cool about them is that they do not replace coding. They are not a simpler version of coding. They are actually designed to work together with code to achieve greater things, which we'll get to in a little bit later. And all the best coding practices apply to blueprints, or you might end up with a train problem. If you see a blueprint like this, you just might need a function or 2 there. Or in a more extreme case scenario, you can have literal spaghetti code, which isn't necessarily the best kind of thing to work with. And the more you look into the whole blueprints ecosystem, you will start to notice that there are actually different blueprint systems, and they actually underneath work on different virtual machines. So as an example, you have animation blueprints, which have animation graphs implemented. You can see that there are states and there are conditions to move from one state to the other, and not necessarily function calls as you saw a moment before. Similarly, there are behavior trees for AI, and they are of course in a tree shape in a certain ordered manner. They move. The ordering is from left to right. That also present some kind of like a flow or like decision flow, which things are going to actually be executed, but they are not like just functions. There's more abstraction there. There are even blueprint systems for sound design, and you can actually randomize a little bit your sounds that you can expect like a more AAA quality or create more variance in your game. We spoke a little bit about writing code, but what about actually debugging it? When it comes to just the code, you can expect like the normal stuff, like you can set a breakpoint, watches, etc., etc. But what's more common in Unreal is like proactive bug detection through assertions. And since you're still working with the compiler from C++, you have all sorts of optimizations issues that you need to watch out for. So as an example, imagine you set a breakpoint in an inline function and suddenly it will never hit, and you may wonder why, and that's because the content of this function was just pasted into the place where it was called, just like inline works. And you need to either disable all the optimizations or try to write some gibberish code just to work around it. And when it comes to assertions, you have a family of three functions like checks, verifies, ensures. And what they do is that they behave a little bit like a breakpoint, but they do not crash, they do not cause any exception in your engine. If the condition in the parentheses is false, they will just kick you out of the engine, they will pause the engine, they will move you into code, you will be able to check what's actually happening, check the values and see what kind of situation happened, and then you can resume as normal, provided it wasn't later an exception. There's also, since of course we are working with C++, there are ways to configure your project that when you run it, that it doesn't load the engine symbols. And if that's the case, you will not see while debugging any kind of information about the functions or the properties from the engine, which tends to be annoying, and you need to work around this by exiting the whole thing and running in a different configuration. This is also something to watch out for. But the most interesting for me features are the actual visual debugging for blueprints. And what you can see here, apart from like the breakpoint that you can set up, like the normal stuff, you've got a tool called Gameplay Debugger. What it will tell you is that it will tell you specific information in the up left corner about a certain NPC that's running around. It will tell you information like what kind of behavior tree is running, what kind of controller is this. And it will visually show you like what kind of path the AI has chosen to follow to your character. All kind of information that's useful to you visually to help you debug, to help you understand what's going on. Another use for it is that it can be used to show you the results of environmental queries, and you can see them in the form of these orbs floating on the level, and you can see which one was chosen, which one has specific grades that were chosen during the environmental query, and in the end you can see which was chosen for the AI to come and to shoot at the player. There's one more feature for visual debugging, and that's Visual Logger. It's a cool little feature that allows you to record the whole play session of your game, and it will then provide you all sorts of different both visual and textual information in the form below. You can then go through the whole timeline at your own pace and just see what's wrong and how it all works together. And as you can see, there's like a moving position of the NPC that was being debugged. You can interface through this. You can interface with this visual logger through C++ only. That's one of the things that C++ comes together with blueprints. And stuff like I mentioned with animation graphs or with behavior trees, you can mostly do only through blueprints as well. But we did some debugging, we wrote some code, but is actually anyone testing anything in Gamedev? And the answer is yes. There's, however, some issues with that. In general, and in my opinion, features change way faster in Gamedev than in IT. Some of the features get thrown away into the trash. Some of them are being tweaked constantly. Some of the features are not finalized, especially in like a prototyping phase. And it all means that maintaining tests is therefore costly. And it's not necessarily a good idea to invest all your time if you're just prototyping a system. So perhaps the question is, when should we start testing and not if we should start testing? And from my point of view, the best moment to do that is probably around switching from production to production from prototyping phase, because that's when a lot of features get finalized and you can tell a little bit more about the context. And of course, Unreal offers a way to run automated tests. And here you can see a spider trying to activate a handle to open the treasure chest, but it's a spider. Spider doesn't know how to use a handle, therefore the test fails. All of this can be also interfaced through scripts. In this way, Jenkins can run these automated tests. And there is one last thing that I want to share, and that's knowledge sharing. What was a big surprise for me when I came to Gamedev is that Stack Overflow and Google is pretty much useless. There is very severe lack of high-quality tutorials and materials online, and there's a lot of things that you need to figure out yourself, which means that each studio will have a lot of tribal knowledge of the right way to do things, but there are no right way to do things, so each studio will do things differently. There are also private forums for cool kids, like the Unreal Developer Network, which are basically forums with support from Epic for developers that have certain deals with Epic, and then you can hope to find some of the answers for your questions. But Stack is going to have mostly indie developers trying to find solution for problems and no one replying. And that would be it for my lightning talk. Do you have any questions? There's a lot of questions in Slido. Do you have to use Windows to work as game dev? In general, yes. There are builds of various engines that were tried for Linux or for Mac, but the general way, 90% of people work is through Windows. And these builds are often either unstable or lack features, or there's something else that doesn't work. When do you plan to release Frostpunk 2? I cannot say. Unfortunately, I'm not planning that. What technology stack is now most popular for game dev, and how about JVM-related technologies? And is it used or rather C++? So, depends what you do. For example, for mobile, Unity and C# is one of the ways to go, and it's probably one of the most popular. For any kind of high performers, when you're trying to push the boundaries of what's possible in games, that's going to be probably Unreal or custom-made engines by specific companies, but not every company has that budget. Even CD Projekt Red lately ditched the Red Engine for Unreal Engine 5. And Java probably is used sometimes in some companies, but it's rare. What about console build sharing? There is no Steam for consoles. Yes, that's a little bit of a problem, and that's why you have that's why you don't share the console builds, and you instead use the tools I mentioned to just playtest them, either remotely or in the office when you have a console. What about GitLFS? I tried using GitLFS personally, and I had some issue with it. But other than that, I didn't see it in Gamedev. But even if it worked correctly, there's still the issue with binary files. And from my experience, because I used to work a little bit in Unity during game jams with my friends, there were a lot of issues when you didn't have this locking. There was a lot of weird things going on with merging levels together after multiple people tried to move a cube 1 centimeter to the left. So you don't necessarily want to repeat that. A lot of isperf is also based on the same concept as Git, like commits tree, etc. In a lot of ways, yes. There are, for example, like one of the big differences is there are change lists that are more local, and they are not necessarily branches. There are ways to share them, but they are at first local for you. And there are like what I call higher order branches, or like higher abstraction branches in the form of streams and depots there that allow you to do a little bit more things. So it's not just branches and commits, but other than that, it works quite similar when you use it. Nowadays, consoles move from dedicated hardware, for example, cell CPU and PS3 to one similar with PC hardware. Does that make it easier to keep unified source code? It's never going to be probably unified source code. There are always going to be like a little differences, and especially when developing for consoles, there are differences that you need to take into account. If you are developing a certain system that's not necessarily out of the box and made by Epic, then you might suddenly notice a bottlenecks for your consoles, and the same system might work perfectly fine for PC. So as the power of the consoles like comes together to what the PC does, I think there will be a little bit less of that problem. But otherwise, like certain console manufacturers keep like their own versions of software that's legit, that's approved, and as a developer, you need to kind of keep in touch with that. Epic does that for you in Unreal Engine. What did you use to make your slides? For the slides, I used Reveal.js and Unreal Engine. Is Unreal? I think we lost one question. Well, what did you use to make your slides that I answered, so you can get rid of that? So, sorry for that question. That if you can ask that question again, it would be cool. Follow-up question: what about multi-platform games or porting from console to PC? Did it evolve into some common patterns, recipe that makes life easier? Not that I know of right now. It's more of a case-by-case basis. It heavily depends on the game, on what kind of features it has, and what it's trying to achieve. Do UI developers encounter any problems with all these UI macros and additions to C++? It seems to me it blows typical C++ code like Lombok does in Java. It's trying, what these annotations are trying to do is actually remove a lot of bloat. There are issues in the sense that there are some assumptions that you are using those annotations. So for example, if you have a pointer to anything that's not marked as U property, then the garbage collector will clean it up, and in any random moment, you must just randomly lose data. So it's more like the other ways. There are problems if you are not using them. But as long as you are using them, it's just that they make life easier in general. And you don't need to like worry about memory management too much if you use them. Failed AA game releases, BF 2042, 002, Cyberpunk. Games are too complex or processes are mismanaged. It's a difficult question. I would say it's the case of different studios and different issues. I would say that there's a mix of both. You can see in the industry studios that are mismanaged, studios that do not like retain developers, and that may lead to like problems later down the line. But in general, there are also studios that try to make different games that they are used to, and it sometimes creates problems, as generally developing games is a quite complicated process, and it's not so easy to just create a new battlefield. Time's up. Oh God. Okay, so no worries to fail the game. Do you write games for each platform? Is why porting takes so much time? It's not so it's not like you write it from scratch for each platform. There's some compilation. There's some like some like builds you can just automatically set from like Unreal to build on. I don't know, for PlayStation. But the problem is that if you are using only like the built-in features, stuff will work fine. But if you have built a lot of custom features or a lot of other functionality, things sometimes don't work or are not performant, or there are issues like that. Sometimes you need to take into consideration that players interface with consoles in a different way than they do with PC, because you have controllers and not necessarily keyboard. And then you need to rethink your input. And I guess the rest of the questions are cancelled, so sorry for that. And so thank you for coming, thank you for your attention.